The unit circle. Dun, dun, dun. All right, so the unit circle is what we have been building up to since we started trig. It's so that you can see how all the pieces fit together. Okay, reference angles, the exact values, and all that good stuff, all the ASTC stuff, all that stuff will come together in the unit circle in a quite amazing way. So that you know, the unit circle is a circle with a radius of 1 and centered at the origin. So if you think about, you've graphed things before on on graph paper and all that stuff. If you think about the radius of 1, the radius of 1 would be, here we go, like that big on a piece of graph paper. Maybe a little bigger, maybe like that. We enlarge it so that we can see it. But it's basically you can multiply you can multiply the radius by anything and make it bigger, but the proportions would still be the same. And that's the whole point of it, making it 1. So basically everything's reduced when we're done. So we don't have to make anything look nicer. So this is the unit circle. So as I said, it's a circle with a radius of 1. And this little spot right here, that's the origin. Now, you can draw any angle, and any angle will cut through the unit circle. And you know that that angle is always, based from the x-axis up. So that angle right there cuts through the unit circle at that point. So what are the coordinates of that point? Well, I don't know the angle, Ms. Bear, so okay, that's not what I mean. I mean, what are the basic coordinates using x and y? Well, if you look at this, if you drop it down like we've done all those other problems, if you drop down that altitude there from the spot that it hits the unit circle, what's created is this nice right triangle again, where this value right here is how far over you went with your x, and this one right here is how high you went with your y. Now if you look at this one, this particular one, because the radius is 1, if I try to find, so the coordinates are x, y. But so if I try to find, like, the sine of theta, the cosine of theta, using these values, these particular values here, what do I get? So using x's and y's and 1's, using this angle here on the unit circle, what is the sine of theta? Well, we do know the sine of theta is the opposite over the hypotenuse. So this is the angle. So the opposite of this angle is y, and the hypotenuse is 1. So it's y over 1, or just plain old y. Awesome. So then this one right here, this is the angle here. Cosine is adjacent over hypotenuse. So the adjacent is your x over 1, or just x. So this is a very big concept here. The sine is whatever value you have here for y, and the x is whatever you have here for x. Like, it's actually the coordinates. So if you found the points on the unit circle all around, and we drew an angle, whatever point it goes through, the x value is cosine, the y value is sine. So that's a big deal. And that's going to explain why the sine and the cosine are positive in certain quadrants and negative. And then tangent, if you also have, it's up, you look at yours, tangent is opposite over hypotenuse. So it is y over x. Opposite over adjacent. I did opposite over adjacent. Okay, it's opposite over adjacent, which is y over x. And aka also known as sine over cosine. So that's a new identity, sine over cosine, which is an important one we're going to be using a lot. So this is the unit circle. right here. And we are going to be labeling all the points all around it. But we need to know what each of these lines mean, what angles they represent, and we're going to be discussing all the points that they go through, which is our x and our y, or our cosine and our sine. So we need to know those things. So let's look down at the bottom for just a second and fill in this little part so that we, it'll help us along the way. So remember, this is like big ordered pair here. So the x coordinate is your cosine, and your y coordinate is always your sine of the angle. So sine is y, cosine is x, and we just did this on the front. Tangent is y over x. So cosecant is just the flip of sine, so it's 1 over y. Secant is the flip of cosine, so that's 1 over x, and cotangent, x over y. And as a reminder, that is cosine over sine, which is an identity we will be using. Okay, so looking at this, we have these three lines here in each of the quadrants. Each of those lines represents a reference angle, and it's the three reference angles that we just went over with the special right triangles. Those reference angles were 30, 45, and 60. So each one of these represents 30, 45, and 60 degree reference angles. So I'm going to write that on there in different colors. So my 30 is going to be blue. My 45 will be red. And try not to use green because, color blindness, but I don't know. I don't know how good orange is. So, and then that one right there is 60 degrees. So each one of these would represent, this one right here, this reference angle here would be 30 degrees. But what is the actual angle? Okay, in quadrant 1, the actual angle, nice bears. In quadrant 1, the actual angle is 30, 45, and 60. But when we measure the angles here and come around, this angle isn't 30. This angle is actually, this angle is actually 150. Now you should know that in radians also. That's 5 pi over 6. I'm going to run out of space, so I'm not going to write it, but it's 5 pi over 6. This one right here in red, if we go 45 degrees back from 180, that's 135. And then if I go 60 degrees back from 180, that's 120 degrees. Okay, so remember, you're actually measuring the angles this way, but remember the reference angle makes it so that the angles have the, you have the radical 3 over 2. It's the same for the sine of 60 here as the sine of 120. It's the same. Okay, so that's the whole point of that. So if you would take a moment and see if you can figure out if this is 30, the reference angle is 30, what's the full angle all the way around for each one of these lines? Okay, take a second and do that, and when you come back, I'll have them on there. All right, so here they are all done. 210, 225, 240, 330, 315, and 300. Okay, those are the angles. So remember the whole box line box thing. If we're in quadrant 4 here, cosine is positive, correct? And if we're in quadrant 1, cosine is also positive. So looking at these sides, it's because the x coordinate's cosine. The x coordinate is cosine. That's why cosine's positive. The y coordinate is sine. That's why up here on these two quadrants, y is sine. Y is positive. And down here, y is negative, so is sine. So keeping that in mind, we can think of the coordinates over here. Now we know all of them are positive because this is the positive coordinates both ways. X is positive, y is positive, so x is positive, y is positive, and then if you remember that this is cosine and this is sine, sometimes it helps you remember ASTC a little better. So remember this one over here, this is all students, Yeah, that's good, Barris. So yeah, okay, I'll fix that. Hold on. So if you remember that this one here is S, we'll just write it as an S. Oh my God, I'm losing my mind here. So write it as an S. So we know that over here, this is the cosine is negative, or the x values here, the x coordinates are always negative in this spot, but the y is always positive because that's going up. The y is positive. So if you remember cosine sine, again, might be easier. Down here is the t that I was so desiring, and we know that this is, in this quadrant, both the x and the y coordinates are negative. And over here, x is positive and y is negative. So that's where the ASTC thing comes from, and sometimes that might be a way for you to remember that also. If you remember x is cosine and y is sine, you know, you can figure out what angle, what quadrant you're in for what angle, and you can figure it out better that way. Okay, so I know you all remember your special right triangles and your exact values. So I'm going to do the first quadrant and see how it goes from there. So we know all the first quadrant angles are the cosine and sine, everything is positive there. But what are the coordinates? So when it hits this point right here, what is the coordinate of those, you know, what's the x and the y? Well, since we know this is 30 degrees here, do you remember what the cosine, 30 degrees here, do you remember what the cosine of 30 degrees is? Well, the cosine of 30 degrees is radical 3 over 2, and the sine of 30 degrees is a half. So the coordinates of this point right here is radical 3 over 2 and a half. Okay? Let's do the next one and see if it gets better. Okay, you have to remember that the x coordinate is the sine of 30. I mean the cosine of 30. The y coordinate is the sine of 30. So this x is the cosine, y is the sine. So right here, 45 degrees. What is the cosine of 45 degrees? Well, the cosine of 45 degrees is radical 2 over 2, and it's the same thing for sine. They're both the same. And then finally, the last one, the coordinates for 60 degrees would be the cosine of 60 degrees, which is a half, and the sine of 60 degrees, which is radical 3 over 2. So these aren't pretty values by any means, okay? In fact, they're all less than 1 because the radius is 1, so those points have to be less than 1. Correct? Because this distance here is 1. Oh, nice, Bears. So this distance here is 1. So when we draw if we're looking for this length and this length, they have to be less than that. Because the hypotenuse of a right triangle is always the longest side, and these two sides are not the longest. Okay, and 1 is long. So they're small values. Okay, and let's go over here to quadrant 2. Now, in quadrant 2, I know sine is positive. So I know when I'm doing my coordinates here, so if I'm going to do my coordinates, it's going to be the exact same coordinates as these. Exactly the same, except the x values over here are negative. So that means this is going to be radical 3 over 2 over here, but it's going to be negative radical 3 over 2 because the x's are negative, but the y's are the same. They're the same height above the x-axis. Okay, they're both the same here and here. Okay, that's it. And it turns out you just keep doing that. That's what the joy of those reference angles. So if you know this is 150 degrees, oh my God. If you know this is 150 degrees, you know your angle's under 50, then you know the cosine is negative radical 3 over 2, and the sine is a half. Done. So if you know this one is 135 degrees, you know it's going to be radical 2 over 2, but you know that the sine is positive and the cosine is negative. So the cosine is negative radical 2 over 2, and the sine is radical 2 over 2. And then this point right here Again, it's going to be a half, but it's going to be negative a half because the x is negative, and radical 3 over 2 is positive because it's still the same height on the x-axis. So this height right here is the same, but over here it's like a reflection in the y-axis. So that's why the x becomes negative. Again, we're going to do the same thing down here. Okay, so these values, these numbers, radical 3 over 2 and a half, those are going to stay the same for this, this, and this spot. What's going to change is the signs. So down here, your x values are negative, and your y values are negative. So when you draw this out, getting my blue, the sign of 210 is negative, or sorry, the cosine of 210 is negative radical 3 over 2, and the sign is negative a half. Over here, this is negative radical 2 over 2. Let me get my, my red. So it's negative radical 2 over 2 and negative radical 2 over 2. So the values are exactly the same. Okay, and that's why we use reference angles. That's why we want to know of, because this degree right here, doesn't matter what quadrant you're in, here, 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 the distance from x and the distance from the y-axis are exactly the same, but their sign is going to be different. I probably could say that one more time, but I might destroy you. Okay, so then this one is negative 1/2, negative radical 3 over 2. See if you can take a second and fill out those other three. Figure out those signs and come back. All right. There you go. This is we're almost done with the unit circle. So notice everything over here, the y values are negative because y is negative down here, x is positive over there. So our y's are the only thing that's negative. The x's are positive, or the cosine is positive in quadrant 4. The last thing that we have to deal with or have to talk about is the quadrantal angles. So maybe or maybe not you remember what those are. I'm going to choose purple, see how that goes. Quadrantal angles are angles that end on the x and y axis. So the coordinates of those points are there. Okay? So the coordinates of those points are your x and your y, are your cosine and your sine also. So take a second, pause, and see if you can figure out the coordinates of each one of these. Okay, so the coordinates of each one of these is, you have to just remember that this distance is the unit circle. So this distance right here is 1. So the x coordinate is 1. It doesn't go up or down at all, so the y coordinate is 0, or the sign is 0. So this is 0 or 360 degrees right here. Right here, so if you go all the way around, it's 360. The cosine of 0 or 360 is 1, and the sine of it, the same thing, is 0. So working our way up here, can you fill that in? So the sine, or the cosine here, sorry, is 0, because we don't go left or right at all, and we go up 1, so that's 90 degrees. We should put that on there. 90 degrees or pi over 2. This is 0 or 360. This one over here is 180, and I deal with the positives, obviously, but it still works with the negatives also, negative 180. So over here, x is negative 1, because it moves over to the negative side. Y is 0, and down here, this is 270. We have x is 0, and y is negative 1. So this tells us, if I ask you what's the sine of 270, you're like, okay, look at 270, sine is y, sine of 270 is negative 1. Done. So we can use these things to find all the reciprocal functions, anything. This is the unit circle, and this kind of encompasses everything that we've done so far. So just take 2 seconds if you can and tell me what the sine of 90 is and all of these. Okay, these particular ones are all the quadrantals, because these are the ones that that are important. The other ones we have triangles and other ways to figure them out. So the sine of 90, remember using the unit circle up at the top, the sine of 90 is up here. This is 90, so the sine is there. So the sine of 90 is 1. Cosine of pi over 2, if we remember the cosine of pi over 2, that's the same as saying the cosine of 90. So the cosine of 90, same spot, that's 0. Secant of 180. All right, so you have to remember your pieces here. So this is secant. Secant is 1 over x. So we're over at 180. The secant of 180 is 1 over negative 1, or negative 1. The tangent of 90, so here we're at 90. It's sine over cosine, or y over x here. It's y over x. So y is 1, x is 0. Remember, whenever you have a 0 in the denominator, that's undefined. Okay, cosecant of 3 pi over 2, that's 270. You can convert it if you need to. So cosecant of 270, so we look over here, cosecant is 1 over y. So 1 over sine. So sine is negative 1. There you go. And then the last one, cotangent of 2 pi. So cotangent is right here, x over y. So it's here. 2 pi is 360 degrees. So that would be x over y, 0 in the denominator, undefined. All right, I hope you understand it. Enjoy. Play it before you want to go to sleep. Have a great day. Bye.